Hi, I'm an old guy and I do maths, and we're looking at yet another compound interest problem. Now, in this case, we've got a sum that you might be familiar with, $1,250. We're investing it at 7.5% per annum, compounding quarterly, so this differs from other videos in this series, which have included 6-monthly and yearly compounding periods. We're using the same length of time that I have in those other videos, 3.5 years, which is 3 years and 6 months, or 14 quarterly periods. There are 4 quarters in each year, 3 fours are 12, and 2 here, which gives us 14. So when I set this up, you'll notice, if you watch the other videos, that there are a few subtle differences. So 1250, I better write the formula here, A equals P into 1 plus R over 100 to the N, or A equals P, capital RN, capital R being what's in the bracket here. So what am I doing? It is times, 1250 times 1 plus, now this rate here is an annual rate. We need to divide it by 4 to get a quarterly rate. So 7.5 divided by 4. There are other ways of doing it. Instead of dividing by 100, you could divide by 400. I think at this stage people might find that confusing, so we'll just do 7.5 divided by 4, which gives us that interest rate for the period that we're interested in, which is 1.875 over 100. Now, just so that there are no mistakes, I'm going to make sure that I get the right number of zeros in here, and I suggest that you do that too, and I'll just make a note of that. That's 0.01875, just there in the margin. That is what this equals. And then we've got our number of compounding periods, which is 14, which I've explained. There are 14 quarterly periods in 3 years and 6 months. Okay, well, let's go to work on this. So if I tidy this up a little bit, what I get is 1.01875, which would correspond to the capital R here. It just makes it easier for working on a calculator. Okay, so let's put our numbers in. $1,250 times 1.01875, which is our annual interest rate divided by 4. And we are raising that to the power of 14, the 14 compounding periods. Let's see what we get. $1,621.28. $1621.28. Now, for those of you who've been watching the series, you'll notice that this is a larger sum of money. I better put a $sign there so that we know that it's money. This is a larger sum of money than we got using the same annual interest rate but compounding differently. So just by way of a very quick comparison, here is the 6-monthly result, everything being the same except for that being the 6-monthly rate and the number of 6-month periods in 3.5 years. And here is the annual one. And again, everything is the same but for that and for that. But what you do notice is that we've gone from $1,610 on a straightforward annual compounding rate up to 1617 and then up to 1621. Now, the lesson to be drawn from that is that as you increase the number of compounding periods, even within the same time frame, you can greatly increase your result. The next move from here is to increase the time period over which compounding takes place. And I'm just going to do that with one example. Okay, so that will be chronologically, I guess that'll be the next one in this series. Thanks very much for watching. I hope you found this useful and interesting. See you next time.